adjacent difference. Very long title. So let's take a look at what this one's all about. I'm assuming it's going to be about arrays, but let's find out for sure. So what is it asking us?
Given an array of integers, find the maximal absolute difference between any two of its adjacent elements.
Okay, so there's kind of a lot to unpack there. I mean, yes, we've got an array of integers. So first of all, what's an integer? It's a whole number. It's something like 5 or 17, or it could be -20, or it could be 0. What could it not be? It couldn't be something like 1.5. It couldn't be something like 7 divided by 11. It couldn't be something like math.pi. It couldn't be e. Basically, it's not going to have anything after the decimal point. It's going to be a whole number. So that's an integer. Could be positive, could be negative. In this case specifically, it's going to be between -15 and +15, so we're not dealing with anything too large in this case. So an array of integers, basically just a whole bunch of whole numbers. And then find the maximal absolute difference between any two of its adjacent elements. Okay, so first of all, adjacent elements, we mean elements that are right next to each other. 2 and 4 are adjacent, 4 and 1 are adjacent, 1 and 0 are adjacent. So those are adjacent elements, and then we want to find the maximal absolute difference. Okay, so first of all, difference, what does that mean? Well, it's a math word, we've talked about it before, and basically it just refers to the result of a subtraction. So if we were to do like 2 minus 4, then the difference would be -2. 2 minus 4 is -2, so the difference between 2 and 4 is -2. Okay, but then absolute difference. So absolute difference means we're not going to look at the negatives. We're looking to look at the absolute value. So -2 is 2 units away from 0, therefore its absolute value is 2. So the absolute difference between 2 and 4 is not -2, it's 2. The absolute difference between 4 and 1 is 3, and not -3. So when we say absolute difference, we mean it's going to be a non-negative value. And when I say non-negative, I'm trying to be careful about that and not just say positive, because technically 0 is not positive, and the absolute difference may be 0 if we had like 2 and then another 2, for example. Okay, and then maximal, I think that's probably a little more self-explanatory. We're trying to find the absolute difference between adjacent elements that is bigger than any of the others. Okay, so we could do something pretty straightforward using a for loop. We could say something like, let max diff be assigned the value of 0. And we've found that sometimes that's not going to work. Sometimes it's going to be an issue if we say that the initial difference, the initial maximum is 0, because maybe it could be that the maximum is actually something negative. But in this case, we're talking about the absolute difference. So this is okay. We don't need to bother with like -1e9 or like -infinity or anything like that. We can just say it's 0 to begin with. Okay, so then basically, for each difference, we could say something like let difference be assigned the value of input array at I minus input array at I minus 1. So basically the current minus the previous. And then let absolute difference be assigned the value of math.abs difference. So that's just going to give us the absolute value. And again, we need to make sure that it's spelled in sentence case. There we go. And then if absolute difference is greater than max diff, well, then we'll say max diff is assigned the value of absolute difference. Might as well. Okay, there we go. And then at the end of all this, we're going to return max diff. Is this going to work? Well, there's one issue with it, as it turns out. Okay, maybe there isn't. But what I was going to say is we're saying input array at I minus 1, when really that's not defined, if I is 0. So basically 0 minus 1 would be -1. There's no input array at -1. I was kind of expecting to get an error about that, but I guess the way it was handling that is... oh yeah, it's hidden. The way it was handling it is it was saying, well, we're basically saying this number minus undefined. So we're going to have some sort of undefined or null. And then basically when it gets to this point down here, it's going to say, well, null isn't bigger than max diff, so it's not going to trigger this part over there. So I suspect that's probably what's happening. But if we don't want to even open up the possibility of that risk happening. So we'll just put in a 1 instead of a 0. So now we're covering all the same ground here. We're basically saying start at this one, but compare it to this one. Then go on to this one and compare it to this one. And then move on to this one and compare it to that one. Okay, so this will work, and there are other ways we could get this to work for sure. Like, well, here's one that's kind of interesting. So math.abs, absolute value. A fun fact is that in math, when we're talking about absolute value, so notation we tend to use is this. The absolute value of x is basically the positive version of that value. So it's going to be x if x was positive already, or it'll be negative x if it turns out that x was already less than 0. And we'll just say greater than or equal to 0 in this case, just so that 0 doesn't end up being negative 0. Anyway, the point is, that's basically what absolute value is. Yeah, that's basically what absolute value is. But the thing is, there's another way of defining it that's a little more efficient, where we don't even worry about this if business. We can just say absolute value of x. This is kind of cool because it also works in multi-dimensions and stuff like that. It's consistent with the derivative of the function. So this is just another way of defining it. It's the square root of x squared. That's it. And I mean, that might remind you of kind of like Pythagorean theorem, or a formula you might use to try to get a norm in a larger dimensional space. But the point is, for this is going to give us the value's distance from 0. So it's the square root of the value squared. And we could do the same thing here. So instead of math.abs, we could do math.squirt for square root. And then difference, we'll just square it. And again, we used to have to use math.pow over here, but now we can just exponentiate. So that's another way of doing it. Take the square root of the difference squared. I don't know if that's more efficient. I kind of suspect no. There's a user on codefights. I just saw this the other day. It was pretty cool. He basically did what was it called? A JS perf or something like that. He was doing like a performance comparison between something that involved exponentiation and something that just involved sort of more classical multiplication and stuff like that. So it was cool to see. So it was a subtle but significant enough difference that maybe we don't want to use this if we can avoid it. Anyway, I don't know how it differs in this case if we just do math.abs instead of all this. Anyway, the point is, this as a problem is it's not giving us too much difficulty. I mean, we've seen ones like this before. We've seen ones more complicated than this before. So we have the tools to deal with something like this now. And maybe we'll just let this be it and say, okay, let's comment this out, and we'll see if there's another way we can do this. So, okay, the way I want to do this is basically I want to do a dot map. So I want to do something like input array dot map, and then we'll take both the element itself, element, and index. We'll use both of these things. And what I want to do is I want to convert this to differences. So in fact, let's just say let differences be assigned the value of input array dot map, and it's going to take element and index to basically element minus input array at index minus 1. And I don't always use these like full variable names. A lot of the time I just call this x and call this I, but just to make it hopefully as clear as possible here, that's our differences array, and we can say return differences. Alright, so just to see what the differences are, okay, null right off the bat makes sense, right? Because we're saying, well, we're looking at 2 minus whatever the previous element is. Well, there's no previous element, so it's not going to give us a meaningful value. It's going to give us null. And then next one, 4 minus 2, we get 2. Then 1 minus 4, we get negative 3. Okay, so that's giving us our differences. Now, if we want, we could just make this absolute differences right from here. We can say math.abs and put that right in here, or we don't have to, like we could do it one step at a time. But now what we should get is our absolute differences. Okay, we're still getting a null for that one, so we could deal with that in a variety of ways, and we'll find out how we're going to deal with that. But before we do, we're looking for the maximum difference here, right? So in this case, it was 3, or maximum absolute difference, I should say. So there are lots of ways we could do that. You know, we could do like a dot reduce on this, compare A to B, that kind of thing. Or we could just do math.max differences. But keep in mind, if we were to try to do it this way, it's saying, well, math.max can't take just one argument. It can't compare one thing. What are you comparing it to? So we're going to spread out the differences. We're going to say all the things in here, find the maximum element out of all of those. And that's still something it's having difficulty with. And the reason is because it knows that differences has a null in it. So it can't really make a comparison between things that involve a null. So one way we could deal with that is we could say, well, this differences thing, I don't want to add anything onto the end there. So I'm just going to say differences is assigned the value of differences dot filter, and then I'll just say x gets mapped to x. Okay, and then from there, I just want to return. Actually, you know what? Just before we go any further, let's just do it like this. So we'll just say return differences.filter x gets mapped to x. And now notice we're just getting the 2, the 3, and the 1. And the reason is because basically the x, keep in mind the way filter works is it's going to typecast the result of the function to a boolean regardless of what it is, and then if that boolean's true it'll keep it in there, if the boolean's false it will not. So right now it's basically just saying, well, is this thing? And it turns out no, it is not, because it's null. So null gets typecast to false. Another way we could do it, we could say something like, well, we haven't really talked about, here, let me not change that for just a minute, and we haven't really talked about type of yet. So type of is something we can do. So what's the type of 5, first of all? What type is this number 5? Or maybe I'll just do a variable called thing, and it's going to start as 5, and yeah, it's a number. There we go. So thing, if thing is 5, then it should tell us it's a number, just like it did before. There we go. Or if it's maybe wrapped in these quotation marks, then is it still going to recognize that as a number? No, it's recognizing it as a string. Okay, and then maybe we want to get more specific. Like instead of 5, maybe we're saying like 5.9 or something like that, right? So now we're talking about a decimal number. Let's see if it makes a difference here. So instead of when it was just 5, it was calling that a number. Well, now it's still just calling it a number. So it's not making a distinction between a number, like an integer and a floating point. So we could be a little more specific. You know, we could say something like number dot is integer thing. So this is a built-in for the number object, and it'll tell us if it's an integer. It's saying no, that's not an integer. What if it was just this 5? Then yeah, that is an integer. We're getting true for that one. What if it was the string 5? Is that an integer? No, it isn't. Okay, so basically there are lots of ways we could check this, but we could say something like filter. We want it to be an integer, right? So we could just go right for this one. Number dot is integer x. And now basically if it is an integer, it'll keep it. If it's not an integer, it will not keep it. And just to sort of show what's actually happening here, let's do a console log of differences, just so we can see what's actually in there before it returns the filtered version. So there we go, not a number. We started out with something that was not a number. So if it's not a number, it's definitely not an integer. We could even say something like type of x. Can we do it like this? Equals equals number. Let's see if that's going to work for us as well. That did not work for us. Okay, why didn't that work for us? Maybe because it's saying it's trying to give us the type of all this thing. So maybe if I put type of x in parentheses, it's going to recognize, oh, you're talking about that, and you want to compare it to the string number. Well, maybe that's a different story, and maybe it'll understand that a little better. It did not understand that better. So maybe we could even do something like this, because we found earlier we were able to do this type of thing, right? So we could say let type be assigned the value of type of x, and that's on one line. And then on the next line, let's just say return type equals equals number. Maybe if we do it that way, then it'll understand it a little better. And no, it's still not. So why is that? I'm not sure actually. Maybe typeof works in a different way than what we imagine. So typeof 5, okay, and then return type. Maybe it's not a normal string or something like that. Hard to say. We'll see. So type is on the value of typeof 5, and then we want to return type. And then of course this stuff isn't going to execute because there's already a return statement above it. So number. Okay, so what if I did that out here? Type is assigned the value, or sorry, type is equal to number. Oh, it's saying true. So I wonder why that didn't work over here. What if it was, well, okay. Maybe this is the issue, that typeof non is, oh, it's saying true there still. Okay, well, that gives us an idea of why the filter didn't work. So what is it saying for type? Number? Okay, what's going on here, JavaScript? You're saying the type of something that stands for literally not a number, you're saying is a number? Okay, so I guess maybe that's a good reason why we're maybe not going to use typeof here. So instead, we'll just say, well, like I said earlier, there are a few ways we could do this. We'd say number dot is integer x, something like that. And we found that that would work. That would get rid of that first element. So we just get the 2, the 3, and the 1. Or, you know, again, if it's just going to be a null, then we just do something like that. Which one is better? Probably the other one's better. You know, probably having all this stuff in here is better. And the reason I say that is because it makes more sense to the reader. It's a little more clear what's going on. To be honest, I'm not really sure how the computation time differs, but something like this is not going to be significant. This is a single operation. This is not going to be the difference between it passing the test in 4 seconds versus not passing. So I don't think we need to worry too much about that. All right, so let's just say let differences be assigned the value of that, and then we're going to, or I don't want to do another let. I should just say differences is assigned the value of that. Okay, and then we're getting our max, and there we go. It's giving us the right values. We can even just grab this dot filter and pop it right onto the end of our dot map over there, and then we don't need to alter differences because that means differences will be kind of the right thing right off the bat here, and we can just, you know, pick this apart so we can see each piece at a time. So differences is input array, and then we do a dot map on it, and then we do a dot filter on that. Okay, and then we do a math.max on that. So, you know, technically we don't even need to have a name for this thing. Like we could just say something like that, right? Put that in and just say return math.max on all that stuff. Oh, it's having an issue. Maybe it's because of that semicolon in there. So let's see if that works. Yeah, that works. Okay, so that's a way to do it. It's kind of messy. I don't really like it too much. I have a better idea. So let's just do a couple undos here. Let's, yeah, we'll do it kind of one step at a time like that. So basically the question was, well, okay, sorry, this wasn't the question, but I'm going to ask it now. The question now is, why did we need this dot filter? Well, we needed it because if we didn't have it, then if we were just returning differences, let's say, then it would have that null element or that non-element at the beginning. It has something that's not a number right at the beginning. The reason is because we're saying, well, we want to map all of this. You know, we want to say, map the whole thing, map all of this array, and then basically for each one compare it to the previous value. Compare this to the non-existent previous value. Compare the 4 to the 2. Compare the 1 to the 4, etc. So since we don't need to make a comparison for this first one, I'm saying let's not include that first one. Let's chop it off. Let's do a dot slice 1. Okay, so dot slice 1. Basically the idea is I'm saying start at index 1 and then go as far as you need to go, like all the way to the end of the array from there. So instead of 2, 4, 1, 0, we would just get 4, 1, 0. 4, 1, 0, like that. We would just get the things that start at index 1 and then go onward from there. Okay, so that's what our dot slice 1 is going to do. So now if we run that, it's just going to return the differences. So we'll see what that's giving us. And once that's done, we'll see what kinds of numbers it's coming up with. Hopefully it's working. There we go. So that's weird. Now we're getting null, 1, and 4. That's quite bizarre, actually. Why are we getting that? How are we getting that? Where are these numbers coming from? Okay, so basically the idea is we're taking our 410 and then we're comparing it. Now, okay, so when we do our dot slice here, now it's just taking the 410. And then when we do our dot map, now it's comparing each of these elements. So this would be element 4, index 0, element 1, index 1, element 0, index 2. And it's comparing that to input array at an index of index minus 1. Now keep in mind we were doing index minus 1 before when we were basically doing the array compared with itself. But now keep in mind this thing right here, since the sliced array is going to start at 4, that means this would be index 0. So we still have this issue with our minus 1. We don't want to do minus 1 anymore because we want to compare it. We want to compare the sliced version. This would be index 0 for the sliced version. We want to compare it to index 0 for the non-sliced version. Index 1 for the sliced version compared with index 1 for the non-sliced version. Okay, so now if we try that, it should probably work better. 2, 3, 1. Great. That's what we were looking for our differences. So that also means we don't need to bother with this step right here. We don't need to do that dot filter if we're doing this slice 1. Furthermore, we don't need to subtract 1 from the index here. So in 2 ways, it's getting a little more efficient. And then from there, basically we're just taking the maximum out of the differences. So that's going to work. No problem. Okay. So let's see. Element, well, I am just going to cut these names down just so that it fits a little better. And then I'm just going to take this whole thing right here, and that's differences. So I'm just going to replace that with what it's equal to. So that'd be sort of like our one-line solution. Is it going to work? Can we run it? Do I have too many brackets here? I'm not sure. No, it looks good. Okay, so there we go. We're getting the right answer. And if we compare our two algorithms, I mean, this is like one line right here versus this whole thing. This is like a lot bigger, a lot more lines, a lot more stuff going on over here. So which is the better method? Well, that's tough. I mean, if I'm looking at this one, we're doing a dot slice. So that's creating another array in memory. So in terms of space complexity, this could get big if our arrays were really going to get big. Thankfully, our arrays are not going to get big. They only get as big as 10. But let's say this was like 100,000. Well, then we would probably want to worry a little more about this because we're creating another array of that size in memory. And then dot map, we're running through that whole array. We're comparing it to this other array. So it's kind of like already we're going through the array twice. We're doing the same operations down here that we did over here. And then at the end of that, we're doing a math.max with a spread on this whole array we just came up with. And so it's basically going through the array again. So it's kind of like we're making a new copy in memory, going through the array 3 times. Whereas when we compare it to this one, we're not creating a new array in memory. We just have these additional variables. This would be like constant space complexity. And then we're running through the array just one time. We're doing the same operations to it, and then it would return the maximum. So I would have to say that this other algorithm is probably better because it's a little more, I think, probably more efficient slightly in most ways. It seems like it's not going through the array as many times, but still that's comparable. That's like a constant multiple, you know. That's like big O of n versus big O of 3n, which is just the same as big O of n. So I don't know. It's probably better because of the space complexity as well, but the main thing is just it's a little more human readable. I mean, someone can look at this and tell what's going on. Then again, some people really don't seem to like for loops. A lot of people will tell you use map and filter and stuff like that. You know, if that's what you're trying to do, right? If you're trying to do something that modifies every element in the array, use a map as opposed to using a for loop. They say that for loops are like a for each is mainly like if you want to do side effects, right? So like for every element inside the array, if you wanted to do something else to it, or have it affect something else, as opposed to just storing a new value within the array. Anyway, so we've got two methods here. Did I submit this? I can't remember. Let's try submitting this. Oh, there we go. Okay, it looks like I hadn't submitted it yet. So great, very nice. All right, so look at this. We're 33% complete in the island of knowledge here. We're a third of the way there, so that means we've completed 20 tasks. Wow, nice job, everyone. Okay, so we're going to finish up with this one for now. Excellent work all around. We've joined the ranks of 6,900 other people who have completed this one, and I have to say, it feels good. All right, so we'll escape out to the